Hello, everyone. Today, our lesson will be about finding the end term of an arithmetic sequence. So, before actually trying to solve the end term of an arithmetic sequence, we should first learn about what exactly is an arithmetic sequence. So, an arithmetic sequence is a sequence of numbers satisfying the condition that the difference between any two consecutive terms is constant. So, what do we mean by that? Let's look at a few examples. First is 11, 15, 19, 23, and 27. Consecutive terms means numbers that are right by each other or next to each other. Consecutive, like 11 and 15, 15 and 19, 19 and 23, 23 and 27. So if you subtract any two consecutive terms in this given, you can see that they all have the same difference. For example, 15 and 11, the difference is 4, same as 19 and 15, and so on. Next is 6, 1, 8, 15, and 22. We can see that if you subtract any two consecutive terms again, all the common differences will be 7. And for our last example, 19, 15, 11, and 7. If you subtract any consecutive terms, we will see that -4 is our answer. So now, let's familiarize ourselves with all the terms of an arithmetic sequence. Starting off with D, which is our common difference, as we mentioned earlier. Next is A sub 1, which is the first term, A sub 1 plus D, which is the second term, A sub 1 plus 2D, which is the third term, A sub 1 plus 3D, which is the fourth term, and A sub 1 plus 4D, which is the fifth term. Now, looking at all the formulas for the terms given, let's see the general term and how to find the general formula of an arithmetic sequence. So, to find the end term, it's a sub 1 plus close open parentheses n minus 1 times d. Therefore, the general term of the sequence is a sub n is equals to a sub 1 plus open close parentheses n minus 1 times d. So now let's focus on actually solving the end term of an arithmetic sequence. Starting off easy, let's look at example number 1. What are the first four terms of an arithmetic sequence if the first term is -4 and the common difference is 4? So, first things first, let us look at what is given in this question. We have a sub 1 is equals to -4, which is the first term, and the common difference is 4. So now, let's plug it in our formulas that we stated earlier into finding the other terms. First, a sub 2, which is equals to a sub 1 plus d, is equals to -4 plus 4, which is equals to 0. Next, a sub 3, which is equals to a sub 1 plus 2d. If we substitute it, it's -4 plus 2 times 4, which is equals to -4 plus 8, which overall equals to 4. Now, finding our last term, sub 4, which is equals to a sub 1 plus 3d, which is equals to -4 plus 3 times 4. It simplifies to -4 plus 12, which is equals to 8. So, now that we have found the first four terms, let's put in a sentence now. The first four terms of the arithmetic sequence with a sub 1 equals to -4 and d equals 4 are -4, 0, 4, and 8. Now, let's look at a different example. Example number 2. What is the 21st term of the arithmetic sequence 4, 11, 18, and 25? Like what we did in the last problem, let's look at the given in this question. We have n, which is equals to 21, a sub 1, which is equals to 4, and lastly, the common difference, d, which is equals to a sub 2 minus a sub 1. And if we substitute it, we get 11 minus 4, which is equals to 4. Now, let's all substitute it in the formula and replace n, a, and d with their given values. So first, let's look at our formula. It is always important to write out your formula first so that you know exactly where to plug in your numbers. So, now, because we're finding the 21st term of this sequence, it is now a sub 21. N is equals to 21. So a sub 21 is equals to 4 plus, open close parentheses, 21 minus 1 times 7. Now, further simplify it. Starting off with the close open parentheses 21 minus 1, we get a sub 21 is equals to 4 plus 20 times 7. Next, a sub 21, which is equals to 4, 20 times 7 is equals to 140, so 4 plus 140, which overall equals to 144. So with that being said, the 21st term of the sequence 4, 11, 18, 25 is 144. Now, looking at our last example, to make it even more challenging, example number 3. How many terms are there in the sequence -8, -5, -2, 1, 4, so on until it goes to 91? So now we're looking for how many terms there are instead of the 21st term or the first 4 terms. Now we're focusing on how many terms. So nothing changes. We try to find the given of what is in this question. So we get a sub n, which is 91, and a sub 1, which is -8. And d, or the common difference, is equals to a sub 2 minus a sub 1. If we substitute it, it becomes -5 minus -8, which is equals to 3. So now, let's look at our formula again. It doesn't change. It's still a sub n equals to a sub 1 plus, close open parentheses, n minus 1 times d. Let's plug it in and replace a sub n, a sub 1, and d with their given values again. We get 91 is equals to 8 plus, open close parentheses, n minus 1, because that's what we are looking for, times 3. So first, we add 8 to both sides of the equation, which leads us to 91 is equals to n minus 1 times 3. And then after that, we divide both sides of the equation by 3, which gives us 33 is equals to n minus 1. And then add 1 to both sides of the equation to cancel it out and leave us with n equals to 34. So, since n equals 34, it follows that a sub 34 is equals to 91, which indicates that 91 is the 34th term of the sequence. So, there are 34 terms in the arithmetic sequence -8, -5, -2, 1, 4, until 91. I hope you understand this lesson today on how to find the nth term of the arithmetic sequence. Till next time.